Good afternoon, students. Today we are going to discuss about the naming of coordination compounds. So yesterday we have seen types of ligands and how to name the ligands. So we have seen list of many ligands. So you have to remember that how to naming the ligands. So hydroxo, cyano, oxo, sulfato. So for negative ligands, we will use this O suffix, chloro, bromo, iodo, like that. So you have to remember all these names of the ligands. So many ligands are there, but I have given only important ligands. So these are neutral ligands. So for neutral ligands, we will use these names aqua, amine, carbonyl. So for negative ligands, we will use O suffix, O as the suffix. So we have seen so many ligands. Ligands means they donate electron pair to the metal. So metal is a Lewis acid and ligands are Lewis bases in these complex compounds. So for example, in this complex iron plus 2. So here Fe plus 2 is the Lewis acid and Cn minus is the Lewis base because it is donating electron. Electron pair donor is the Lewis base. Electron pair acceptor is the Lewis acid. So let us see the rules in the naming of complex compounds. And first we have to see how to write the formulas of coordination compounds. So first see the rules behind the writing the formulas of compounds, then we will go to naming. So first see the rules in writing the uh, formulas of mononuclear coordination compounds. So mononuclear coordination compounds means, so mononuclear means they contain only one metal at the center. Nuclear means central. So mono means one. So there is only one metal atom is there in the central of the compound. So let us see. The first rule is cation first followed by anion. So in writing the formula of a coordination compound, so we have to write the first formula of the cation and then followed by anion. For example, K4FeCN6. So we have written potassium first, K4 in formula. This is the cation and this is the complex anion. So first we have written cation and then we have written anion in the formula. So this is the rule. And next, so here K is the K plus potassium plus is the cation and FeCN6 minus 4. So how this minus 4 will come? So potassium is plus 1. So each potassium plus 1 means how many potassiums are there? 4. So total plus 4. Here the charge is plus 4. So to balance this plus 4, the sphere should contain minus 4. So that's why here the minus 4. So this complex anion is named is written after cation. And here CO cobalt NH3 taken 6 Cl3. So we have written first this part. So this is the complex cation. So because it is not simple, it is complex in nature. So that's why we will call it as complex cation. So here this is the cationic part and this is the anionic part. So first we have written in the formula cation and then anion. So what is the cation here? Cobalt NH3 taken 6 plus 3. So how this plus 3 will come? So because each chlorine is minus 1. So each chlorine is minus 1. How many chlorines are there? 3. So minus 3. So here the charge is minus 3. Means the sphere contain plus 3. So that's why here this is the complex cation and chlorine is the complex anion. Sorry, simple anion. So here Cl minus anion and this is the complex cation. Next, second rule. For the coordination pair, central atom first, ligands in alphabetical order. So, in writing the coordination pair, so first we have written here, this is the coordination pair. So, in this first what we have written metal. So, central metal atom has written first and followed by ligands, and these ligands are written in alphabetical order. So we are seeing the rules in writing the formulas of coordination compounds. In that formula, first we have to mention cation, then anion. So if complex ions are there, so if the cation is complex cation, then we have to write metal first, then followed by ligands. So these ligands are in alphabetical order. They should be written in alphabetical order. And this polyatomic ligands means many atoms. For example, water, NH3, ammonia. So in ammonia, how many atoms are there? Nitrogen and 3 hydrogens, 4 atoms. In water, 2 hydrogens and 1 oxygen, 3 atoms. So these are polyatomic. Monoatomic means Cl. For example, chlorine is a monoatomic, only one atom is there. So for polyatomic ligands, we use this brackets. So we enclosed in this bracket. So for example, so this is the formula. First we have written metal, then ligands, and these ligands should be in alphabetical order. For example, this is the amine. We have seen in the naming of ligands, we have seen amine. So in amine, A is the first letter, and in nitro, N is the first letter. Which comes first in alphabetical order? A first. So that's why we have written first ammonia and then nitro ligands. First metal followed by ligands, and ligands should be in alphabetical order. So and here we have enclosed these polyatomic ligands in these brackets, right? So these are the some rules. And there should be no space between central metal atom or ion and ligands. So there is no space should be there between metal and ligands. So there is no space here between metal and ligands. This is the rule. So these are some rules in writing the formula. So let us see writing how to name the complex compound. So the rule 1, the first rule is cation is named first followed by anion. Here also we have to name the compound first cation and then followed by anion. So whether it is simple cation or it is complex cation. So whether it is simple cation, for example, potassium, K plus is the simple cation. And if you see this cobalt, hexaamine plus 3. So this is complex cation. So we have seen in this. So this is the complex cation. So whether it is simple cation or it may be complex cation, we should name cation first followed by anion. And in naming of complex ions, the ligands are named in the alphabetical order. And in this complex ion, so first we have to name the ligands and then followed by metal. So this is the rule. And next rule is use prefix di, tri, tetra for if more number of same kind of ligands are there. So for example, here NH3 taken twice means how many ammonias are there? 3 ammonias. That's why we use prefix tri. So here how many water molecules are there? 6. We will use prefix hexa. So means if more number of same types of polyatomic ligands are there, then we will use monoatomic or polyatomic. Then we will use the prefix. di, tri, tetra, penta, like that. Next rule. If ligand's name already contains any of these prefix, for example, in the name of ligand only di, tri is there, for example. So then we will use bis, tris, tetra, kis. So means these prefixes are used instead of di, tri and tetra. So for example, so this is the ligand. NH2, CH2 taken twice, NH2. So this is ethylene diamine. So here two carbons are there. We will use ethylene and diamine. So this is ethylene diamine. In shortcut we will write EN. EN means ethylene diamine. Already we have seen in the ligands, types of ligands. So here, for example, two ethylene diamines are there. So in the name only di is there. So if ligand contain this type of di, tri, tetra, then instead of di, tri, tetra, we will use bis, tris, like that. So for naming this ethylene diamine, we will, for example, two ethylene diamines are there, we will use the prefix bis. So this is the third rule. And next, so we will see another example. NiCl2, nickel Cl2, PPH3 taken twice. So in this complex, first we have to name the ligands, right? So how many ligands are there? Cl is there, PPH3. PPH3 means triphenylpaspene. Triphenylpaspene. So see, two ligands are there. First we have to mention ligands, then followed by metal. So in these ligands, first we should mention which comes alphabetically first. So here this is the chloro and this is the triphenylpaspene. So which comes first? Chloro. So in this complex, so NaCl2 PPH3 taken twice. And then these ligands are named in alphabetical order. So how to name this complex ion? Let us see. So this is the cationic complex ion. So this contain -2 and nickel contain +2 charge. So this is the complex cation. And here how to name this? So first we have to mention ligands. Dichloro. So how many chlorines are there? 2. That's why we have used dichloro. And here triphenylphosphine. So in this ligand tri is there. For this ligand the tri is there. That's why instead of using di we will use bis. Okay, bis. So here these are two ligands are there. That's why we will use bis. Bis triphenylpaspene. So the name of this ligand is triphenylpaspene. And next nickel followed by metal. First ligands, then followed by metal. So metal is the nickel here. Nickel. And here this Roman 2 is oxidation state. So oxidation state of nickel in this complex is +2 oxidation state. And we have to mention oxidation state or oxidation number in Roman letters only. After metal, we should mention oxidation state in Roman letters in enclosed brackets. So here the oxidation state of nickel is +2. So let us see NiCl2 PPH3 taken twice. So this is the complex. So chlorine is the negative ligand, PPH3 is the neutral ligand. So chlorine is the negative, means oxidation state of one chlorine is -1, means total oxidation state -2. So if we assume that this nickel oxidation state is X, for example, this is a -2 plus X equal to, here there is no charge, 0. So means X is +2. So means nickel oxidation state is here +2, and we have to write in Roman letters and then in closed brackets. Next rule, if the complex ion is a cation, so if the complex cation is there, the metal is named same as the element. So means for nickel we will write nickel only, for silver we will use silver only, like that. So there is no change in the naming of metal. But if the complex is anion, if complex ion is anion, while naming of metal, we should write the suffix ate to the metal. So the metal ends with the suffix ate. So for example, if you see K4FeCN6. So here this is the simple cation and this is the complex anion. So if the complex ion is anion, the name of the metal ends with the suffix ate. So here in this name we have written ferrate. So first ligands are named first, then followed by metal, and this metal name ends with the suffix ate if the complex ion is anion. So if it is simple anion, there is no change. But if it complex ion is the anion, then we should end the metal with ate. That you have to remember. So let us see this compound, how to name this K4FeCN6. So what is the first rule? First we have to mention positive part. Potassium is the positive part. So we have named the potassium, and then this is the complex ion, complex anion. First we have to mention ligands. So what is the ligand here? Cn. And how many are there? 6. So hexa, cyano, and what is the metal? Iron. So but here this is the complex anion. That's why we have ended this metal with 8. Ferrate. And we have mentioned oxidation state of this metal iron. So how to calculate oxidation number? So for example, in K4FeCN6 we don't know Fe oxidation number. So what is the oxidation number of potassium? So this is K4FeCN6, right? So how it dissociates into K4K plus, right? And then FeCN6 minus 4. So this is the complex anion. So how to calculate oxidation number of iron here? So Cn have -1 oxidation number. So how many Cns are there? 6. So -6 and plus, if it is x equal to -4. So x equal to +2. So this is the way to calculate oxidation state of metal. So we have mentioned in the Roman letter. So this is the name of the compound, potassium hexacyanoferrate 2. And let us see one more example, K3FeCN6. K3FeCN6. So first we have to mention cation, potassium. Then this is the complex anion, right? So that's why we will use 8 suffix here. Potassium cation part is over. Then complex anion, first we have to mention ligands, hexacyano. How many ligands are there? 6. That's why hexa prefix. And then cyano, hexacyano, and metal, ferrate. So why we have written ferrate? Means it is a complex anion. That's why we have mentioned 8 here. So if metal is in anion part, complex anion part, we have to mention 8 here. And then oxidation number of iron. Iron is in +3 oxidation number. So next Next example is chromium H2O taken for Cl2Cl. So how to name this compound? So in this compound, Cl is -1, means it is a simple anion, means it is a complex cation. So this is the complex cation and this is the simple anion. So first we have to mention cation. In that, first we have to mention ligands. So tetra aqua. Why we have mentioned here aqua first? So because it is alphabetically comes first. Tetra aqua dichloro. So two are there. That's why we have added di. Here tetra. Tetra aqua. So water is over and Cl is over. Dichloro and metal. Chromium. Chromium and oxidation state of chromium is +3 and then anion part chloride. So the name of this compound is tetra aqua dichlorochromium +3 chloride. So how to calculate oxidation state? See once. So this is the chromium. You don't know oxidation state of chromium. So this complex dissociates into Cr H2O taken for Cl2 plus and Cl minus, because Cl contain -1, this pair contain +1. So this is the complex cation. So assume that X is the oxidation state of chromium, X, and here water is the neutral ligand and Cl is the -1. So -2, we have mentioned -2, and equal to, what is this charge, total charge of sphere? +1, and X equal to +3. So means chromium oxidation state is +3 and we should mention in Roman letters in enclosed brackets.